The leave schedule for room specialists has shown that with our new $1.101 billion toy, it is likely to be a while before things progress as expected. If everything goes as planned, the journey to Proxima B will take roughly 20 years. However, realistically speaking, it might take a few years just to confirm if there's any life on that planet. The ongoing investigation into whether we are truly solitary in the universe continues, sparked by findings from the James Webb Space Telescope, JWST. This telescope has already uncovered some incredibly interesting phenomena from far beyond Earth, possibly bringing us closer to answering this long-standing question. Our drive to understand our place and significance in the cosmos has always been fundamental to human nature, leading to countless productions and theories throughout history. Our curiosity about space, paired with feelings of isolation, compels us to keep searching for other life forms. Even though we are just specks in the vastness of the universe, we may be getting closer to the answers we seek. But are they really the answers we want, or are they simply unsettling discoveries? Join us as we explore the most recent findings in the fields of systems and exoplanets, embarking on a journey that may lead us to confront something we're not yet ready to understand. In 2021, experts made a monumental leap forward, possibly one of the greatest scientific breakthroughs of all time, with the launch of the James Webb Space Telescope. This prompted an intriguing hypothetical question about the power of our technology. Could future telescopes detect artificial light on distant planets like Proxima B? The closest exoplanet to Earth, located 4.25 light-years away, Proxima B was found to have a permanent day side and night side, similar to the Moon. An advanced civilization on Proxima B could potentially harness energy from the day side and transfer it to the night side using photovoltaic cells that convert sunlight into power. A paper co-authored by Manis Ving and other scientists demonstrated that a vast array of solar panels could be placed on the day side, with future telescopes linking to them. With the JWST upgrades, our ability to search for artificial lights on planets like Proxima B has expanded. The fact that JWST was able to detect these lights in 2024, thanks to its enhanced capabilities, marks a revolutionary moment. The JWST might have found the very lights we've been searching for, potentially launching humanity into a new phase of exploration. Let's dive into the world of planets and exoplanets to understand how this discovery became a reality. Since the beginning of recorded history, humans have wondered about the vastness of the universe. Who we are, where we came from, and where we are going. These timeless questions remain highly complex despite our technological advancements. We are still left wondering if we are any closer to answers. A scholar might argue that we are still at the early stages of understanding our role in the cosmos, while an astronomer would likely get excited to share the latest discoveries made possible through advanced tools. These instruments, often underappreciated by the general public, represent humanity's ongoing progress. We now have access to the universe, and it's time to push forward using the knowledge and technology that brings the cosmos within reach. One of the key advancements in this effort is the creation of the James Webb Space Telescope, JWST, a tool that holds the potential to answer some of humanity's most profound questions. The JWST represents humanity's attempt to probe the mysteries of space and seek answers to ancient questions. Are we alone? What is our purpose? And where are we heading? This powerful infrared telescope is actively working toward those answers. If you're wondering about Proxima B, it's sometimes called Proxima Centauri B or Alpha Centauri B. This exoplanet is considered a super-Earth and orbits an M-type star. You might be unfamiliar with the term super-Earth, so let's clear that up. Super-Earths are planets that are larger than Earth but smaller than gas giants like Neptune or Uranus. They can be made of rock, gas, or a combination of both. These planets range in size from twice Earth's mass to several times that of our planet. Proxima B is one of these super-Earths, and like other exoplanets, it orbits outside of our solar system. The first indications of exoplanets appeared in 1917, but it wasn't until 1992 that the first confirmed discovery astonished experts. Another exoplanet initially identified in 1988 was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 systems hosting more than one planet. Many of these exoplanets orbit around M-type stars. To understand M-type stars, it's crucial to know that they are the smallest stars in the main sequence and are often called red dwarfs. These stars are widespread in the Milky Way, but their faint light makes them hard to detect. M-type stars have temperatures around 3000 Kelvin, which is relatively cool compared to other stars. Proxima B's host star, Proxima Centauri, has a mass about 1.07 times that of Earth. Interestingly, Proxima B only takes 11.2 days to complete one orbit around its star, much shorter than Earth's 365.25-day orbit. Proxima Centauri is quite faint, emitting just 1.6% of the Sun's total visible light output. Most of its energy is emitted in infrared radiation, accounting for over 85% of the total. Proxima B orbits its star at a distance between 0.045 and 0.056 astronomical units, which is much closer than Earth is to the Sun. Discovered in 2016, Proxima B has captured significant attention. Despite the existence of millions of other stars, planets, and galaxies, there are several reasons for this. First, it's the closest known exoplanet to our Sun, just 4.2 light-years away. While 4.2 light-years may sound vast, it's relatively close in the grand scheme of the universe. Proxima B is part of the Alpha Centauri system, a triple-star system. Despite Proxima Centauri's faint light, the Alpha Centauri system is still one of the brightest objects in the night sky, trailing only Sirius and Canopus. Perhaps the most fascinating thing about Proxima B is its potential habitability, as it lies within its star's habitable zone, where liquid water could exist. This raises the possibility of life on the planet. For these reasons, astronomers are eager to explore the habitability of Proxima B and other exoplanets like it. This is where the James Webb Space Telescope becomes essential. The JWST has four primary objectives: studying the light from the first stars and galaxies formed after the Big Bang, investigating how stars and planetary systems form, understanding the development of stars and planets, and exploring the origins of life. As the JWST continues to investigate exoplanets like Proxima B, we are getting closer to achieving these goals. The search for exoplanets and extraterrestrial life is not only about answering scientific questions. It also reflects human curiosity. Throughout history, humans have been driven by an insatiable desire to explore and understand the universe, both animate and inanimate. This curiosity led to the creation of the Search for Extraterrestrial Intelligence, SETI, a long-standing effort to find signs of life beyond Earth. SETI is one of humanity's most ambitious endeavors, akin to a cosmic game of hide-and-seek, with our planet searching the vast universe for any trace of intelligent life. The search for extraterrestrial life began in the 1960s when astronomer Frank Drake first detected radio signals from distant stars. Though this groundbreaking discovery didn't result in contact with extraterrestrials, it marked the start of a serious effort to detect such signals. Despite the challenges, the search continues, with recent technological advancements such as the JWST bringing us closer to potential breakthroughs. As the JWST continues to monitor exoplanets like Proxima B, there's growing hope that we might find definitive evidence of extraterrestrial life. If such evidence is discovered, it could completely alter our understanding of life, intelligence, and the nature of the universe itself. Even if no direct evidence is found, the detection of artificial signals or light from distant planets would still be profound, suggesting that intelligent life might be far more common than we once believed. While the excitement surrounding these discoveries is palpable, they also raise important questions about how humanity would respond if we were to confirm the existence of extraterrestrial life. Would we approach this discovery with scientific rigor, respect, and curiosity, or would it provoke fear and uncertainty? Humanity has often reacted unpredictably to major revelations, especially those that challenge deeply held beliefs. This raises further moral and ethical questions. If we were to encounter intelligent extraterrestrial life, what responsibilities would we have? What ethical framework should guide our interactions with other forms of life, whether microbial or advanced? These complex questions will likely become central to our understanding of our place in the universe as we continue to explore. As we venture deeper into the cosmos, the potential for encountering extraterrestrial intelligence or life raises both thrilling possibilities and profound uncertainties. The discovery of even microbial life elsewhere in the universe would profoundly impact humanity's understanding of biology, evolution, and the nature of life itself. It could validate the hypothesis that life is a common phenomenon in the universe, rather than a rare accident. However, the moral and philosophical implications would be immense. How should we approach beings from another world? Should we attempt communication, or would that pose unforeseen dangers? The risks of contamination, both biological and cultural, are not trivial. If an encounter with extraterrestrial life were to happen, what protocols would be put in place to ensure the safety of both parties? The scenario of finding alien life forces us to confront difficult questions about human nature and responsibility. For instance, would our technological superiority grant us the right to intervene or influence the course of extraterrestrial civilizations, or should we adopt a policy of non-interference? The potential existence of intelligent life elsewhere also challenges humanity to reconsider its place in the grand scheme of the universe. For centuries, humans have considered themselves the pinnacle of life on Earth. Discovering extraterrestrial civilizations could radically alter this perception, humbling us and forcing us to recognize our own limitations. In addition, the implications of such discoveries on society would be far-reaching. Human history is marked by instances when the discovery of new frontiers or life forms has caused societal upheaval. The discovery of extraterrestrial life would likely spark a cascade of social, political, and religious debates. Many people might be excited, others fearful, and some perhaps skeptical or dismissive of the findings. Governments and international bodies would need to collaborate on how to best handle such information, creating frameworks for cooperation, regulation, and perhaps even defense. Furthermore, the search for extraterrestrial life also touches on existential questions. What does the discovery of life beyond Earth say about our purpose? Are we just another link in a vast cosmic chain? Or do we possess a unique role in the universe? These reflections would not only shape scientific discourse but would influence art, philosophy, and culture. Humanity's place in the cosmos has always been a central theme in literature, cinema, and art. The reality of extraterrestrial life would inspire new generations of thinkers to reimagine what it means to exist in a universe filled with other sentient beings. On a scientific level, the search for extraterrestrial life offers exciting avenues of exploration. As technology advances, we are increasingly able to detect potentially habitable planets, study their atmospheres, and analyze the chemical signatures of life. Instruments like the James Webb Space Telescope provide the capability to identify biosignatures, such as oxygen, methane, or other compounds associated with biological processes. The discovery of such signs on distant exoplanets would propel humanity into a new era of scientific inquiry. By studying these exoplanets, we could learn more about the conditions necessary for life to arise and how life might adapt to environments vastly different from our own. The development of space exploration technologies has also brought the possibility of interstellar travel closer to reality. While current propulsion systems are far from capable of reaching even the nearest stars in a human lifetime, breakthroughs in areas like quantum propulsion or antimatter could one day make interstellar voyages feasible. As we push the boundaries of what is possible, the dream of traveling to planets like Proxima B or even farther afield becomes less like science fiction and more like a long-term goal. While Proxima B remains the closest exoplanet that might harbor life, it is far from the only one. The discovery of thousands of exoplanets, many of which lie in the habitable zones of their stars, has expanded the potential for finding life across the galaxy. Some scientists suggest that the sheer number of potentially habitable planets means that life could be common throughout the Milky Way. If this is true, the odds of discovering intelligent life in our lifetime could be higher than previously thought. However, the challenge lies not only in detecting these planets but in understanding the nuances of their environments and determining whether conditions are truly suitable for life as we know it. One of the most fascinating prospects is the idea that life elsewhere in the universe might not resemble anything we recognize. Earth life is carbon-based, but other forms of life might use entirely different biochemical systems. Life on other planets might be based on silicon or might even exist in environments that we consider inhospitable, such as on gas giants or moons with subsurface oceans. This opens the door to the possibility of life forms that do not adhere to our preconceived notions of what life should look like, further broadening our understanding of biology and the adaptability of life. In addition to finding life, the search for extraterrestrial intelligence, SETI, continues to inspire excitement and speculation. If we were to detect a signal from an advanced civilization, it would not only confirm that we are not alone, but it could also provide an unprecedented opportunity to learn from a more advanced species. However, the question remains whether such civilizations are out there, and if so, why we haven't yet received any signals. The Fermi paradox, why, given the vastness of the universe, we haven't found any signs of extraterrestrial civilizations, remains one of the great unsolved mysteries of science. It could be that intelligent civilizations are rare, or perhaps they are deliberately avoiding contact with us, or that they rise and fall before we have a chance to detect them. As we push forward into the unknown, one thing is clear. The quest for knowledge about extraterrestrial life is more than just a scientific endeavor. It is a journey of self-discovery. By searching the stars, we seek not only to understand what lies beyond, but also to better understand ourselves. The discovery of alien life, whether microbial or intelligent, would force humanity to confront its place in the universe and challenge the assumptions we hold about our uniqueness. In the end, this pursuit of knowledge is part of a larger journey, a journey to answer the questions that have always haunted us. Are we alone? And if not, what does it mean for humanity to share the cosmos with other beings?